I'm Tamas, and I'm here to talk about internationalized domain names, also known as IDNs. Why we need them, how they come to be, how they work, and where things are at right now. Let's start with a few words about DNS. With DNS, the domain name system, you can attach human-readable labels to remote computers, making the web a lot more convenient to use. It does come with severe limits, though. They are restricted to just 37 characters, the 26 letters of the English alphabet, numbers, and dashes. There's another important constraint as well. DNS allows 63 characters for each part of the domain, separated by the dot, and the complete domain can be more than 255 characters, including the dots. All of this is a very English-centric approach that excludes everyone else, and that's bad. And this gets us to our main topic, IDNs. First of all, why should we care about IDNs? Well, for one, not everyone can read Latin characters. People who are not well educated or live more isolated or, kids. The world has loads of languages and cultures who have every right to use their own language and or writing system. I don't think any of this is a hard sell in 2019, but our story starts much, much earlier. So to put things into perspective, let's start with some history. DNS itself has been around since the mid-80s. In 1989, Tim Berners-Lee invents the World Wide Web, and 2 years later, the first web browser, Mosaic, becomes available to everyone, and we all know the rest of that story. Before we continue our history lesson, though, let's make a brief detour to Unicode. Unicode is a huge table with over 1 million entries, also known as code points, where each code point is a character, ideogram, emoji, whatever. It's usually represented with the U plus hexadecimal characters format. Unicode was created to have a comprehensive collection of every writing system ever, and became instrumental to the web and computing and everything around that. It made the way for much more flexible encodings than what we had before, ones we use today. Unicode kind of looks like this. This is the beginning of the Unicode table. You can see the Latin characters and some symbols, etc., and it goes on and on and on. Going back to our history lesson, Unicode also came a long way. People started working on it in 87. It wasn't until 91 that the first standard was released. UTF-8, a variable width encoding that we all love and use on the web today, the variable length bit will become important soon, didn't arrive until 93, and Netscape Navigator, the dominant web browser at the time, only started supporting the charset meta tag in 95 and Unicode in 96. Consumer versions of Windows only started fully supporting Unicode from XP in 2001. Emoji didn't even make it in the Unicode standard until 2010, mostly thanks to Google and Apple. All of these things we take for granted today, Unicode, UTF-8, emojis, not setting your browser's encoding manually, are not as old as we might think they are. Because back in the mid-90s, where our story really starts, we were still in the early days of the web. Every content had its own encoding, and if your main language was not English or a bunch of other Western ones, well, sorry, ISO 8859-1, aka Latin one, can't help you. Please find your own encoding and deal with the problems that come from that. And that's what people did. UTF-8 largely solves this for the content, but domains were a different story. And now we take another brief detour to UTF-8 to see how it works. UTF-8, what we use on the web today, encodes the first 128 characters in 1 byte, the next almost 2,000 in 2 bytes, and then 3 bytes up to 65,000 whatever, and then finally 4 bytes for the rest. This is great for content, but working within the constraints of DNS to conserve space and to have the ability to include as many non-Latin characters as possible, something even more compact was required. The work began when in 1996, Martin Durst from the University of Zurich proposed IDNs and encoding for it UTF-5. By then, DNS was widely used, so whatever the standard and encoding for IDNs come to be had to fit within its existing constraints. 37 characters, 63 characters per part, 255 characters total. That's not a lot to work with, so people had to get creative. UTF-5 is kind of like UTF-8, but encoded in just 32 characters, just shy of the available 37. Let's look at an example. Here's the URL straight from 1996. is.s.u-tokyo.ac.jp, which roughly means information.science.university of Tokyo.academia.japan, which written in Japanese is this. And if we transliterate it, we get yoho.ri.todai.gaku.nihon. The Unicode representation of that is this. And finally, the UTF-5 version is something like this. You may notice the .i in the end. That was a proposed TLD, a top-level domain for internationalized domains. And here it is all summed up, the domain, its meaning, written in Japanese, etc. To illustrate this, I made a little table, which you can see on the top of the slide. The Japanese, the Unicode representation, the UTF-5 version. You can see that the UTF-5 version looks almost the same as the code points, except for decoding purposes, the first byte is mapped to a character between G and V, since 0 and F is used for hexadecimal characters, which helps separating the characters as well. So U plus 6OC5 becomes MOC5, 6 becomes the M, etc., etc., etc. There's a table for that mapping on the bottom of the slide. The variable length bit I mentioned earlier, the thing that UTF-8 does as well, is the fact that it omits leading zeros where it can. In the case of our Japanese domain, it can't because it's already working with 4-bit characters, but I've put an example on the slide where it does omit the leading zeros. All of this was fine, but it had its limits, the biggest one being length, which was still the main issue. About 15 ideographs in the case of East Asian languages, or for example, 21 Hebrew or Arabic characters. Still, it was a good starting point and people got to work. So, more history. In 1998, a working group was formed, and by 1999, there were several test implementations. Taiwan launched the first internationalized TLD called .gongxi, roughly meaning .com, in Chinese characters, and they sold 200,000 domains within a week. The second commercial IDN launch was in the Tamil language in India, a few TLDs that mapped to .com, .net, .org, and .edu. All of these, however, required using either a plugin or DNS hacks. Neither of them are optimal. In November 2001, the ICANN IDN committee was formed, and in March of 2003, things finally became standardized with 4 RFCs. The most important one for us being RFC 3492, the star of the show, the standard for Punycode, the spiritual successor of UTF-5, the encoding we use today. Punycode took the idea proposed with UTF-5, using a variable with encoding, and took it to the extreme. These are the domain names we see today as xn-whatever-blah-blah-blah.com. Let's get the easy part out of the way. Why the xn-? It's the AC prefix, where AC is a shorthand for ASCII compatible encoding. It's to inform the browser that the domain encoded in Punycode is coming. The way things are encoded in Punycode are not pretty, but incredibly efficient. Instead of storing every code point encoded like they did with UTF-5, Punycode basically makes a big bet. A given domain name will likely be in one language, and the given language's code points are usually close to each other in Unicode. So what if we just encode the lowest code point, and then for the subsequent ones, we just encode the distance between them? It also separates the standard first 7 characters into one group and puts the rest at the end, encoding not just their values, but their positions as well. All of these are stored in something called generalized variable length integers, which you can read more about in the spec. It's outside of the scope of this talk to fully explain them. The example people usually use is bukhev.example, which translates to accent-bcher-kva.example. You can see how the basic characters are grouped together, and the U is encoded after the final dash into kva in this example. There are a bunch of other examples. The poop emoji.la translates to that. A domain that got briefly internet famous like 11 years ago was the snowman.net, which is not actually an emoji. It's part of the other symbols group of Unicode. The final example, which leads us to our last section of the talk, would be apple.co, which surprisingly translates into that. And the question is why? Well, of course, because I'm using the serial characters of A, R, C, and O, which look just like the Latin ones, and these are known as homographs. Homographs are a big issue and used a lot by bad actors for phishing and other malicious purposes. This is obviously bad, and is the reason why today many browsers won't always display the IDNs as IDNs, but sometimes show the Punycode representation instead. Most browsers have complex algorithms in place to decide what to show when. You can read more about it. Both Mozilla published the algorithm, and there is one for Chromium, etc., etc. This can be an even larger issue on mobile nowadays, where it's common to hide the URL. You don't see the URL you're clicking in the first place. There are lots of talks about this, so if you want to learn more, just go to YouTube and search for IDN homographic attacks. Homograph attacks. So where does that leave us? Since 2003, we have several dozen IDN TLDs in Hindi, Japanese, Chinese, and so on. Most regular TLDs support IDNs, though support for emojis remains scarce. The examples I gave above are mostly exceptions from the early days. The reason emojis are not well supported is because there is a standard for domains that was, I think, last changed in 2008, and back then emojis still didn't exist, and so they're not quite standard compliant. But if you want to register emoji domains, there are 14 TLDs that let you do that, and they work in browsers. The most popular one would be .ws. There are 7.5 million IDNs as of December 2017, which amounts to just 2% of all the domains on the internet. All modern browsers support IDNs, though for reasons mentioned earlier, some will not always display them, but you can always use them for input. There's a whole movement out there for supporting IDN emails, for which support is still severely limited. In conclusion, IDNs are great, though not without issues, but you can use them for both fun and profit. Thank you. You can find this presentation at the URL, and I put all my references and links in the final slides. Which, yeah. So thank you.